again, this is the continuation for our topic about moment of inertia, or we can also call this one as the second moment of area. So the problem is, we're going to determine the second moment of area with respect to the x-axis of a parabola. X is equals to ky squared with base a and a height h. So again, for those nga karon lang naka-attend or who have not yet seen the previous video, the moment of inertia or the second moment of area denoted as I, no, gidenote na as I is equal to the that is equal to the square of its distance, no, that is r square times its area. Okay, times its area. And then in this problem, we're going to apply or we're going to use integral calculus to solve for the second moment of area. So here we are given a parabola with this equation, x equals to ky squared, and then we're going to plot this one on a Cartesian coordinate plane in order to visualize sa iyahang forma. So again, we already discussed this one, no, on how to draw this parabola by just looking at the term that contains the exponent square. So since this is x equals to ky squared, pasabot this parabola either opens to the right or left. But since, as you can see, no, that is x equals to ky squared, the y squared term, this one, this is positive, so therefore this parabola opens to the right. So mano siya ay forma. Okay, so this is our parabola with equation x is equals to ky squared. And then of course, we have we have base, no? The base of this parabola is a. Okay, so meaning na limit up to here, and of course it has its height. So na po ang limit diri. This is the height h. Okay. And now, in order to perform the integration, no, we're going to select a very small area, and in our centroid discussion, we call that one as a smaller rectangular strip. And that area, okay, by the rules of integration in this problem, no, for the moment of inertia, ang rule ani niya is that the area, no, or the rectangular strip should be parallel to the axis. So since in the given, since in the problem, it is stated here that with respect, okay, with respect to the x-axis. So meaning this parabola right here, the area that is being covered by this parabola will tend to rotate along the x-axis. So man siya nga to ang probable nga rotation aning parabola. So since our axis is the x-axis, so our differential area or our rectangular strip should be parallel to the x-axis. So yan ang pagdrawing. Okay? And of course, this rectangular strip has a width of dy, and then of course it has a length of L. And this small, okay, this is very small rectangular strip, of course, it has its centroid, no, or it has its arm or its r, okay, right here. So you can see from the formula of moment of inertia, I is equals to r squared a, the r here stands for the distance, okay, the distance of the object, no, from its centroid, So the center of this rectangular strip is at the center towards the axis. So we're going to label that one as y. Okay, I hope nag-take down notes mo dira ah. So na siya. So this information or these parameters or variables are already enough so that we can start the integration. So the generalized formula for the second moment of area, no, is I. And of course, don't forget to write the subscript kung asa siyang axis. On where or on what axis are we going to rotate this area. So that is along the x-axis. So Ix is equal to, again, this is the integral of the square of the distance. So our distance here is denoted by y. So that is y squared times this very small area, kaning rectangular strip nga ako shadean. Now, our area, okay, our area or our differential area is just equal to the length L times its width, that is dy. And then we all know that the L, okay, the L kani siya pila may height ani, no? Pila may measurement aning length. So the length here is equivalent to A, okay, minus this one right here. This is x, okay? X na siya. Okay, at that particular point, no? That point along the x-axis is equal to x. So therefore, our L is just the difference of the base A minus kani siya, minus x. Okay, A minus x. Considering that we are concerned with this particular point that is along this rectangular strip. Now, substituting dA and L on our integral equation. So we have Ix is equal to the integral of y square tapos A minus x dy. Now, ang ato ang limits of integration. So, ang atong limits of integration magdepend sa kaning increment nato. So, since this is dy, so ang atong limits kay values along the y-axis. So, our area starts from 0, no, 0 nga y value up to y is equals to the height of this parabola. So, that is from 0 to h. Now, kung imo makita, no, observe nato that the integral equation, no, the variables are not uniform because we have variable x, and then our dy, no, our differential coefficient is in terms of y. So kailangan we need to find a relationship that exists between x and y, okay? Or that is, we are going to solve x in terms of y so that we can come up an integral equation that is uniform or usara ka variable ang present. How about for a, sir? So a is not a variable. A is a constant. So no need to worry about this one. Okay? So asa man ta makaog relation sa x. Now, the statement sa problem that the equation of the parabola kanang kuan relates x and y. So that is x is equals to ky square. Now, to get rid of k, no, because k is a parameter, and if we're going to substitute that one directly, nanaputay unknown nga k. Now, since naman tayo usa ka point, known point on the parabola, which is the topmost part, we all know that this point, no, has a value of x equal a, and then y equals h. Kung yung makita, no? So therefore, in solving for k, at x is equals to a and y equals h, so our k is equal to, that is x over y squared or that is equal to a over h square. So na siya. And with that, our x di, therefore our x is equal to, we have k, which is a over h square times y square. And now we are ready to substitute x in our integral equation. So balik ta, we have our ix is equal to integral from 0 to h. We have y square tapos a minus a over h square, and then this is y square, that is dy. Next, we're going to distribute y square, no? So from 0 to h, we have a y square minus a h square, this is y to the fourth dy, and then we're going to integrate each of these terms. So use power rule. We have a y cube all over 3 minus, this is a y to the fifth over 5 h square, and we're going to evaluate this one from 0 to h. Now diri ata, therefore ix, if we're going to evaluate these two terms by 0, automatic magzi-0. So we need to evaluate na lang these two terms at i-set y is equals to h, because if we're going to set y is equals to 0 here, automatic mag-0 ning duha ka terms. So only h, we only evaluate these two terms in terms of h. So letting y is equals to h, no, by the rules of integration, we can obtain a, this is h cube, no, all over 3 minus, this is a h to the fifth all over 5 h square. So simplifying, a h cube all over 3 minus, this is a, then we have double h, so kanang rules of exponent for kanang division. So we have h cube all over 5. Now they have the same numerator, ah cube. So we have a h cube, and then we have 1/3 minus 1/5. Now if we're going to subtract this one, the result is 2 over 15. So we have 2 a h cube all over 15. And this one is our final answer. That is the moment of inertia, or the second moment of area of this parabola with respect to the x-axis. So this is how we are going to find the second moment of area by integration. So naay pangutana? Sige, this is now your time, no, to ask questions. Okay, basig ngadto na sa kuan. Kusog mo tana biya ni guman quiz. Kung discussion di mo tana. Okay, walay pangutana. Wala na? Okay. So, kamo wala magha. So we have our next topic, that is polar moment of inertia. So based on the book of Singer, the moment of inertia for an area relative to a line or axis perpendicular to the plane of the area is called the polar moment of inertia. Maybe karon maglibog pa mo ani, but ato siya i-breakdown, no? So starting with the moment of inertia, because there is a huge difference between polar moment of inertia and just simply moment of inertia. So again, moment of inertia sa ta. Moment of inertia. So again, mostly sa ato mga problems or calculations, it is very kanang kuano kanang comfortable to put our object or our 2D figure on a Cartesian coordinate system, no, because it is easy to analyze. So in terms of y and x, if we have this figure, no, it could be any figure. It could be a triangle, a rectangle, or a circle. So it depends upon you. Now, the moment of inertia for this object, let's say for example, this object has an area of A. Okay, this object has an area of A, and again, this object has a distance, no, a distance of y, no, from one of the axes, and that axis is the x-axis. So again, be mindful that this distance should be, no, should be from the centroid. So nag-discuss sa matag centroid mo na ang kinatung-an or kung asa nag-concentrate ang area baka or ang mass object. So starting from the centroid up to the axis. And of course, not only that, this object also has a distance, no? Na po siya distance from its centroid towards the other axis. And that axis is the y-axis. So, sa simple nga definition for moment of inertia or second moment of area, so we have I is equal to, again, this is if this is a complex, no, okay, i-DA na lang nato differential area. If this is a very complex nga kanang object, so we're going to use integration. So that is integral, and that is, we have again the moment of inertia, no, the moment of inertia is always associated with the axis. So kailangan mo na ka, okay, if you want to take the moment of inertia, then unsa man imong reference axis. So here we have two axes, known axis. We have the x-axis and the y-axis. So let's start with the x-axis. So the moment of this area along x-axis is evaluated by the integral of its distance, dapat naka-square. So square of its distance multiplied by the differential area dA. Okay, what else? So we also have moment of inertia along the y-axis. That is the integral of its distance, no, from that axis. So the distance is x. It should be square. So x squared, and we have here dA. Okay, so kaning duha, these are the moments of inertia of this object with respect to these two axes, the x-axis and the y-axis. And we already through with this one, no? I already give some examples. So katong sa previous nga slide, usa to siya sa mga example ang parabola. Now this time, move ta sa polar, okay? Polar moment of inertia. For the polar moment of inertia, so still it has an axis. However, from the statement above, that axis or line, okay, should be perpendicular, no, perpendicular to the plane of the area. So here, if we have this Cartesian coordinate plane, so this is y, this is x. If this is our area, same area lang gyapon, no? Assuming that this one is a complex area and this is its centroid. So still nagyapon siya differential area. Now, we have here an xy plane. So ingon man diri nga ang polar moment of inertia has or is defined as the moment of inertia relative to an axis that is perpendicular to the plane. So unsa may axis sa perpendicular ani? So that axis is either towards the screen, no, of your cell phone or away from you. Okay? So ato lang ipaana lang, no, assuming this is a kanang 3D plane. So for the polar moment of inertia, mo na siya ang iyahang axis. So kana ang giswat. And pwede na ta siya ato i-denote as z, no? Z. So diri iyahang axis of rotation. Again, only kuana siya. Tendency lang siya nga mo rotate. Tigid siya ingon nga mo rotate siya sa tinuod. That is a tendency only. So now, ang pagkuha ani, no, ang pagkuha ani sa polar moment of inertia along this z axis, so kailangan makaibaw ta sa distance sa kaning area, no, ani nga axis. Okay, ani nga z axis. So that distance is again defined from the centroid, no, from the centroid towards this line. Okay, so since the line, no, since the line coincides with the origin, so dira ata kutob taman, and we can denote this one as rho. Okay, now again napotay kuan, we all know that this is y and this is x. Okay, mana siya. So using this using this illustration, we can say that the moment of inertia along the z, or we can call that one as the polar moment of inertia. Some books uses j to denote that this is the polar moment of inertia, is equal to again the integral of its distance. So this time aya distance is kaninang rho. So that is rho squared tapos the differential area. Now, by using Pythagorean Theorem, no, ato na siya i-extract, naka-create ta og right triangle. So this is y, this is x, wherein we all know that rho square is equals to x square plus y square. Okay? So, na kuan ba? Nasundan? Nakasunod ra? Okay. So, we are going to substitute this one, no? We're going to substitute this. So, that is equal to the integral of, we have x square plus y square dA. Now, we can separate this one. So, that is the integral of x square dA plus the integral of y square dA. Kung naka-observe mo, x squared dA is just equal to iy, di ba? Iy. So therefore our j is equal to, this is iy, x squared dA plus y squared dA is ix. So iy plus ix. So this is the generalized formula for our polar moment of inertia. Now, gamit ka na siya. Say for example, if we have a rectangle, no? If you have a rectangle, so siyempre, kung along the centroid, no, naatay moment of inertia along this one, ato like one as along OX and along OY. So kung pangitaon nimo ang polar moment of inertia along the centroid, so that is equal to JO. Now, ang JO lang is to denote nga that is along the centroid. Kaya syempre, malahi-lahi man ang polar moment of inertia at a particular location. So, maglahi-lahi. So, JO is just, again, sum ra, no? Sa kanang moment of inertia at that centroid along x-axis plus moment of inertia at that centroid along the y-axis. So, that is the purpose of the polar moment of inertia. This time, you cannot appreciate this topic, but sa inyong higher subjects, if taparan kini siya mga formulas sa inyong strength of materials, sa inyong machine design, then makaingon na ka nga this is very significant. So again, that's the difference for the moment of inertia and the polar moment of inertia. Okay, so let's have our fourth example. No, ato to i-apply tong polar moment of inertia. So here, the problem is determine the polar moment of inertia of a rectangle having a base B equals 3 inches and a height h equals 7 inches with respect to an axis perpendicular to the plane and passes through the centroid of the rectangle. So ang una buhaton is, of course, we're going to illustrate, no? We're going to illustrate the 2D figure on the Cartesian coordinate plane. So we have here y, then we have here our x. So this is our y, this is our x. So since at the centroid man, no, passes through the centroid, so therefore the origin is at the center of the rectangle. So this is our rectangle. Mana siya? So the rectangle has a base B, and we have a height of h. Okay. So ang ato ani is, we all know that the general formula for the polar moment of inertia is J equals, again, along O. So pasabutan ng O is at the centroid. Is equals to IOX plus IOY. Meaning, ato ni siya, sulbon tagsa-tagsa. That is how we're going to solve this kind of problem. So first is, syempre, start ano. So mag-start ni IOX. So we can use integration here. So since ako magidot nga IOX, meaning ang ato ang axis ani is the x-axis. So ato siya tend to rotate along this axis. So again, same sa atong gibuhat sa parabola, magrepresenta og rectangular strip, and that rectangular strip again should cover our object and should be parallel to our axis of rotation. So paana man atong gidrawing. Okay, so kana siya. And of course, it has a width of dy and a length, no? This length right here. Okay. And of course, this one, na siya distance nga y with respect to the x-axis. So the general formula, again, IOX is equal to the integral of its distance, that is y squared, the area. Now we all know that the area, okay, dA is just equal to L dy. But we all know that L is equal to the base of this rectangle, diba nara? Obvious kayo. So substituting, we have base times dy. Now for the limits of integration. So since ang ato ang differential coefficient, which is dy, is along y-axis kay y man, so along y ta. So pasabot ana asa man ang mga utlanan or the boundary of our object. So along the y-axis naa siya diri sa ubos kaning kinaubsan. What is the value of this one? So that is negative h over 2. So y h over 2 kay nagsugod ba ng 0 at the center of this rectangle. So ang ubos is 1/2 of the height, ang babaw is 1/2 pod of the height but positive. Okay? So the limits of integration from negative h over 2 to positive h over 2. So next, ato ipagawas si b kay constant man na siya. So si b kay constant, so pagawas. Then integral negative h over 2 to h over 2, and we have y square dy. So since uniform naman ang variable nga naa, so integrate directly. So we have b y cube all over 3. That is from negative h over 2 to positive h over 2. Now, ato siya i-simplify further. I-evaluate nato, no, from these two boundaries. So we have b times, we have h over 2 cube all over 3 minus h over 2, this is negative, cube all over 3. So that is equal to, again, base times, this is h cube all over. So 2 cube is 8 times 3, that is 24, minus. So ang kanin siya, negative h over 2, erase nimo to the third power, the answer is still negative. So negative h cube all over 24. Now, mahimo na siya og b times, this is ma-positive na. So, maduha na siya. 2h cube all over 24, or simply that is equal to bh cube all over 12. So that is our IOX. So again, our IOX is equal to b h cube all over 12. So, i-note na siya. Kaya di pa na siya may final answer. So, walay kuan ani? Walay pangutana ani nga part? Ang limits of integration, nagbase ta sa drawing, sa rectangle. So, since ang differential coefficient, which is dy, kay along y man, so kayo makita sa y-axis, di ba? Ang utlanan, or ang boundary sa atong rectangle, no? Nag-ana man na atong rectangle, nag-ana. So, naaman, 0 naman ang pagbasa ani. So, the total height of this rectangle is h. No? H na siya. This is the y-axis. So, half of that one, no? Nas ubos. So, kay mao man ang x-axis, so ang pagbasa sa below ana is negative na, di ba? Negative h over 2. Then, the value pod at the topmost part is positive h over 2. Kaya kung imo na i-add, okay, kung imo siya i-add, ang answer is h. Okay. So, nakuha ra? Sige. Wala yung pangutana ang uban? So, proceed ta for the y. So, number 2, we have IOY. So, ato na po i-drawing balik. This is our y, this is our x. Again, this is our rectangle. But this time, since ang atong ipangita kay moment of inertia along the y-axis, so ang atong axis of rotation is 3 na po sa y-axis, and our rectangular strip should be parallel to the y-axis, so pa-vertical na po siya, unlike kaganiha nga pa-horizontal. So, paana. And its width, kay since kani siya kay horizontal man iya width, so that is dx, and ang length is L. Ato lang butangan og L. Again, remember, given tawag height sa tong rectangle and also its base. Okay, its base B. Now, following the generalized formula for moment of inertia, we have IOY is equals to the integral. Okay, palitan natin denote ang distance aning rectangular strip with respect to the y-axis. So, this is x, no? Kay horizontal man. So, that is x square dA. Now, our dA is equal to the length, no? The length times dx. But, no? Ang atong length sa atong rectangular strip is constant, and that is equal to the height of this rectangle. So, mahimo siya integral x squared h dx. So, sunod na pod ang limits of integration. So, since our differential coefficient is dx, so along x na pod na to ang boundaries ni ani. So, ang kani siyang padung left, no, kani siya nga point, this is negative b over 2. Okay? Katunga man sa b. Kani pong nasa right, this is positive b over 2. Kaya again, ang atong differential coefficient is along x man. So, that is from negative b over 2 to positive b over 2. Now, si h nga nasa sud, this is constant, no? So, ato i-factor out sa gawas. We have h integral x squared dx from negative b over 2 to b over 2. Now, walay problema sa kanang variable kay uniform kayo siya. So, proceed dayon, IOY is equal to h, tapos that is x cubed all over 3 evaluated from negative b over 2 to positive b over 2. Now, you must simplify. So, h, we have b over 2 cubed all over 3 minus b over 2 cube all over 3. I forgot to put here negative. So, if ato na siya i-simplify further, we have b cube all over 2 cube is 8 times 3, 24. This is minus. And if cube gate nimo, ma-minus gihapon na siya. So, we have negative b cube all over 24. So, therefore, ma-add na ma-plus. So, if we're going to add these two terms, the result is h b cube all over 12. So, this is our I o y. Okay, naipangutana ani? Pangutana? Wala na? So, ang next na to, for the third step, so managid ni, ato na pangitao, no? Ang J. So, ang JO, again, this is the polar moment of inertia, is equal to the IOX plus IOY. So, our IOX kaganiha, that is BH cubed all over 12 plus our IOY is gibaliktad ra, HB cubed all over 12. So, factor out ang 1 over 12. So, we have BH cubed plus HB cubed. So, kay given man, no? Given man ang values for the base. So, given the height equal to 7 inches and the base equal to 3 inches. So, our base 3 times the height 7 cubed plus the height 7 multiplied by the base 3 cubed. So, therefore, our polar moment of inertia along the centroid, so we're going to use our cycle. So, we have 1 over 12 multiplied by 3 times 7 shift cube plus 7 times 3 shift cube. So, we have 101.5 inch to the fourth. So, we have 101.5 inch to the fourth. So, this is our final answer. So, naipanguta na? Okay, wala. So proceed ta sa next nga topic, that is about the radius of gyration. Now, according to Singer, radius of gyration K, gidenote na siya as K, this one, is frequently considered to be the uniform distance from the reference axis at which the entire mass may be assumed to be distributed. So mathematically, K is the square root of the quotient of moments of inertia I and the area A of a given plane figure. If we're going to interpret the second paragraph, now we can quantify that the radius of gyration K, no, K is equal to the square root daw of the moment of inertia all over the area. So again, ang moment, the radius of gyration, the same with the moment, it depends upon the axis and the location. Kay ang radius of gyration is function man siya sa moments of inertia. So unsa may purpose aning ato ang radius of gyration di ay. Now, kung inyo man gud makuano, kung inyo ma-observe, the moment is equal to mostly the integral of y square dA. Okay? And for the rectangle, we have this generic formula nga bh cubed or over 12, no? bh cubed or over all over 12. That is with respect to the centroid, di ba? If this is with respect to the centroid. Ana. Now, mas maayo man gud og ang ato ra makita, no? Ang ato ra makita or ang ato ra may bawan is just simply a formula, no? A formula that will, no, quantify the area times the square of this distance, no? No, para sayon ra ba? Say for example, hatagan kag area sa usa ka object, no? So, may ba nimo ang moment of inertia and then you are given with this R, no? So, kadyot ra. Instead of memorizing these formulas for each plane figures that we have just derived using integral calculus, diba? BH cubed over 12. Mas sayon ma-memorize ang area, no? Ang area sa kanang mga figures. Let's say for rectangle, we all know that is base times height. For triangle, that is 1/2 base times height. So mas madali siya, and then ato po din siya ma-interpret easily. Say for example, if we have this axis, x-axis, and then if we have this area, no, very complex nga area, and assuming that the distance of that area, no, is r, no, so we can say nga this area is very concentrated, no, and it tends to rotate along this x axis. So this r ang gikuan is simply the radius of gyration. Kay if mag-apply tag integration man good, very long kay sa yung process. Let's say for example, ang complex, of course, yung pa siya gimawag mga strips, no? Gisum up nimo tanan, and then gimultiply pag tag sa ilang mga distances, so on and so forth, in order to come up a formula. But if ato ikuan, ato i-sum up siya, no? And then ang kaniyang mga distances, no? Ato mo gani ipang kuan gud ipang break into smaller pieces, then ato ni kon y1, then napoy kay y2, napo kay y3, no? Why not having why not having a single nga distance, no, nga mo concentrate or mo kuan niya, mo represent aning entire nga area. Okay, given that this object is very complex, why not having only a single area, I mean single distance k or r. So kanang possible na siya, and that single distance nga mo justify aning area aning object is known as the radius of gyration. So ato na gi-represent aning mathematical equation. Now if we're going to rearrange this one, taking square both sides, may ano na siya, I over a, and then solving for I, that is equal to a area k squared. No? So this is another formula for the moment of inertia, that is equal to the area of the object. Any object, it could be complex, as long as you know its radius of gyration. So this is the radius of gyration. Then you can easily, no, you can easily solve for its moment of inertia without without performing those lengthy integration. Again, given lang ni nga hatagan ka sa iyang radius of gyration. Okay? So, mo ni iya main advantage. If given ang radius of gyration, ang imo na lang problem, your only problem was to identify its area. Okay? So, you need to familiarize this one. K equals square root of the moment of inertia of the object all over the area. Now, we have here an example nga mag-utilize siya sa radius of gyration. Sample number 5, find the radius of gyration of a circle of radius r equals 6 inches with respect to its diametral axis. So, mo ni siya ato ang circle. This is y, this is x. So, with respect to its diametral axis, so daghan makinig lines of, daghan may lines sa iyang diametral axis. It could be the x-axis. Sorry, murag wala na to nga ang coordinates, but at assume na nga na siya sa center sa circle. So you can have this diametral axis kaning y-axis, or you have this x-axis, or you have this axis, or you have this, so on and so forth. So daghan kay mapilian nga axis. Para kuan lang, para masabtan na lang, you can choose either of this axis na given. So pwede na to mo choose og x na lang, kaya lang x. So again, ang formula for the radius of gyration, we have k equals the square root of the moment of inertia of this circle along the diametral axis all over the area of the circle. Now, ang moment of inertia of the circle, if you have already watched the previous nga video, ang moment of inertia for the circle along the diametral axis is equal to pi r to the 4 all over 4. And of course, we all know that the area of the circle is equal to pi r square. Everyone know that one. I hope kay bapon money. This is very simple nga formula for the area of a circle. Next, ato na siya i-substitute sa equation. So, ID is pi r to the 4 all over 4. Again, if you want to know the derivation of the moment of inertia for a circle along the diametral axis, you can watch the previous video. So, kani, this is pi r square. So, makancel ang pi, makancel ang 2 ka r, what's left diri is r squared na lang. So, therefore, we have the the square root of, we have r square over 4, and that is equal to r over 2. So, therefore, the radius of gyration of a circle with respect to its diametral axis is just half of its radius. So since our r is equal to 6 inches, so therefore we have 6 inches divided by 2, and that is equal to 3 inches. Okay? Now, unsa may gamit aning radius of gyration? So, if we do it in reverse, no? In some problems, if um, i-ask sa inyo ang moment of inertia, no? So, it's okay if you don't know this one. It's okay if you don't know this one, no? As long as you know the radius of gyration, because ID is just equal to the area of the circle times the square of its radius of gyration. As long as you know the radius of gyration, the formula, then you can directly solve for the moment of inertia. So our final answer, again, for this problem is 3 inches. May pangutana ani? Na? So we have the transfer formula for moments of inertia. So ni-arise na siya kay there are some instances that we need to find the moment of inertia from one axis to another parallel axis. So the transfer formula accounts this method. So sa may kon ani significance ani. Why do we need to include this one? Why do we need to study this one? Say for example, you have this coordinate system and you have a rectangle here, no? Kunya, mo ni siya yung centroid. The axis of its centroid is this one. This is O. Now, assuming nga ang imong na-solve ra kay ang moments of inertia of this rectangle along its centroid. Marag na may buad that is equal to BH cube all over that is all over 12. Okay? So far, more na ato ang nahibawan. Now, in reality, okay, or in other situation or in other problems, syempre, di ba pwede puro na lang along centroid, di nga na ang statement. Labi na gyud sa actual, di magiging nga na. So there are some cases that ato pangitaon ang moment of inertia of this rectangle, no, on another axis, given that that axis should be parallel to the given axis. So unsa may given axis nato diri kani siya, kani ang hidden lines. So makagamit ra kaning transfer formula if the other axis is parallel to the given axis. Say for example, sige daw, pangita daw ang moment of inertia along this axis. So kani, this let's say this is axis XX. So imo sa kitaon if this axis XX is parallel to the given axis. So given axis nato kay kaniman hidden lines, so they are parallel with each other. Then you can perform transfer formula, no, or the parallel axis theorem. You can use the parallel axis theorem. Now, if the axis is inclined, no, paana, let's say for example this one, this is YY, no. So di na to magamit ang parallel axis because the axis O and the axis YY, they are not parallel to each other. So kung gusto man ka mangita, so kani nga centroidal axis imong gikinahanglan. Let's say this is OO. So now OO is parallel to our line or our axis YY. So yung ana, again, not all the time nga ang hatag ra is ang moment of inertia along the centroid. Pangitaan jud kag moment of inertia at a different axis. And that axis again should be parallel dapat sa iyahang given nga kanang kuan axis. Okay. So ang ato diri no? Ang ato diriya is ato ni siya i-derived kaning parallel axis theorem. So we have here, no? We have here x and y axis, and then natay a very complex nga object, and this is its center of gravity. So this is the centroidal axis denoted by O. So syempre nata dira ay saman natay distance, no? Natay distance nga kanang, let's say, d, ato lang i-abbreviate as d. So meaning this is the distance of the centroidal axis with respect to the x-axis, assuming that we're going to rotate this object along the x-axis. So wala siya. So kung at the centroid, sayon ra na naman tayo mga generic formulas, but on a different axis, wala pa. So manang we're going to use this theorem. Now, since this is complex, this is a complex object, then mogamit tag integration, no? Meaning mag-select ta og small area, and that area again should be parallel to our chosen axis. So our axis is along x-axis, so magbutang ta dira og, let's say we have the rectangular strip. Okay, kana siya. So it has an area of dA. Now, the distance, no, of this rectangular strip with respect to the centroid, or with respect to the centroidal axis, so na siya distansya. Ato lang siya i-labeled as y. Okay, ato siya i-labeled as y. We don't know that one. Okay? So, muna siya. Now, applying the general formula for the moment of inertia. So, we have moment of inertia that is along x. No? Moment of inertia along x is equal to the integral of the distance. So, since mao na siya to ang differential area, to babaw, so ang iyahang distance is d plus y squared times the differential area. Okay, again, d plus y siya, kaya toras babaw ang ato ang area of interest. Now, ato siya simplify. So that is d square plus 2dy plus y square dA. Now, to distribute, so we have integral d squared dA plus this is 2d integral of this one is dy, no? Okay, kuhaan pa ni nani siya naparin ni siya y, napa ni siya diri ay y. So 2dy dA tapos plus integral y square dA. Now, kung inyo ma-notice, ang kani siyang y square dA, okay, but the integral of y square dA is just equal to what? So, kani nga dA class, no, na siya distance y from the centroidal axis. Actually, that is the moment of inertia of this object with respect to its centroidal axis. Now, what else? Sa pa may lain. So, ang kana siyang kuan class, ang kana to yung integral d squared dA, no? Our d here is a constant, no? D is constant. So, ma-simplify na siya into just d squared, and then the integral of dA is just simply the area. Okay, now the middle part, so we have 2dA, 2d integral y dA. So may equivalent ana niya. Now ang iya equivalent ana, no? Ang y manggod, y here, no? Y represents, no? Y represents the centroid. The location day, no? Ang location na niya. Now, since ang ato ang pagkuan ani, no? Since ang ato ang kuan ani is along the centroid man, padung matag center of gravity on the centroid. So therefore our y here is equal to the location of the centroid, and that is equal to 0. Kaya ang kaning y magtikaabot man ni siya ang centroid. So magtika 0 ni siya. So therefore this expression is equal to 0. Okay? Kaya at the centroid man. Therefore, ang ato ang moment of inertia along x is just equal to, we have the centroid plus the area times its distance, d square. So this is the general formula for the parallel axis theorem. Now, kato siya gamiton. Say for example, on the xy plane. If we have here a circle, then of course we have an axis, centroidal axis. Nitama siya sa iya centroid. This is O. Now, kung mangita ta sa iyang moment of inertia along the x-axis kani. So syempre, hatagan jud kag distance. So this is the distance. So therefore, the moment of inertia along x is just equal to the centroidal moment of the circle, that is maguna sa ka sa iyang centroid plus sa area ana nga circle times iyahang distance d. Then square nimo. Okay? So yan na siya. And not only circle, what if natay triangle diri no? So same lang gyapon, kailangan ibaw ka sa d. And then follow this general formula. Okay, nasabtan na? Naka-follow ra? So, proceed ta. Katong ato ang formula for parallel axis theorem, actually ma-apply po to siya for the polar moments of inertia. So, follow lang the format. Again, the moment of inertia at any axis is equal to the sum of the moment of inertia along the centroid plus the area of the object times the distance of these two axes square. So applying this general nga kanang formula, so applying for the polar moments of inertia, so kanila yung duman. So the polar moment of inertia at an any axis, no, is just equal to the polar moment of inertia at the centroid plus the area of the object times the square of these two distances. And with the polar radii of gyration still the same, so we have the radius of gyration at any axis, so ato lang siya i-represent as diri para di maglibog kaganiha siya i-represent as z, so ato lang siya i-z jz. Diri pod kz is equal to, again, this is the radius of gyration at the centroid plus the area of the object times the square of its distance. So ano na, again kaniya to ang transfer formula, magamit po ni siya for determining the polar moments of inertia and also for the polar radii of gyration. So we have our example number 6. So we have determine the second moment of area of a rectangle with base B equals 3 inches and the height h equals 7 inches with respect to an axis parallel to the lower base and 2 inches away from it. So to illustrate, we have here, so this is our xy plane. We have the rectangle. So mani ato rectangle. Of course, our rectangle have a base of 3 inches. 3 inches. Then we have a height of 7 inches. So we all know that ang ihang centroid kay naa diri. So this is axis O. So this is half, no, half of the height. So this one is equal to 7 divided by 2 inches. Now, ang atong problem nag-require nato, no, to find the second moment of inertia, second moment of area or the moment of inertia with respect daw to an axis parallel to the lower base. So this is the lower base and 2 inches away from it. So 2 inches away, so kani siya, no? So this one measures 2 inches. So this is, let's say this is axis XX. So again, ni conform man tano tungod kay ang axis nga XX is parallel to our centroidal axis O. Now, ang atong DRE is kani siya from the centroid, no, to our axis XX. So D. Now applying the parallel axis theorem. So we have the moment of inertia along our new axis, which is XX, is equal to again the the moment of inertia along the centroid O plus the area of this rectangle times the square of its distance. So again, kay ba naman ta sa moment of inertia for a rectangle along its centroid, so that is BH cube, no, all over 12, and then plus we have BH, no, the area of the rectangle is base times height, and then we have D square. Now our D here, D is equal to, that is 7 divided by 2 minus 2. Okay, so gamit calculator, 7 divided by 2 minus 2, so that is 3 halves or 1.5. So 1.5 inches. So ato na siya i-plug in ang values. So the base is 3 inches. The height is 7 inches. So cube divided by 12 plus the base is, this one is 3 inches. The height is 7. The distance is 1.5 tapos square. So kung ato na siya i-solve, we have 3 times 7 shift cube divided by 12 and then plus 3 times 7 times 1.5 square. So the result is, that is 133. Okay, that is 133 inch to the fourth. So 133 inch to the fourth. So this is the moment of inertia of our rectangle with respect to an axis that is parallel to the lower base and that is 2 inches away from it. Okay? So naay pangutana? Yes, oo. Naa diri sa formula. Kani. Maklaro ni nimo? Na, okay. On okay na. So mo ni siya. Let's say mo ni centroid O niya. Ingon man ako no nga this axis XX is 2 inches away from the base. So ang distance ani again kani siyang centroidal axis towards the axis XX. So D na siya. Okay. So ay ana. What else napay pangutanang uban? Okay, wala na. So let's have example number 7. Last na lang because it's already 5:13. So determine the moment of inertia of a triangle of base B equals 4 inches and altitude H equals 6 inches with respect to an axis that passes through the centroid and parallel to the base. So maing ani gali no nga dili siya moigo sa yang centroidal axis no nga if the problem states that you're going to solve the moment of inertia on a different axis other than the centroidal axis, then you can use the parallel axis theorem or the transfer formula, no? The transfer of axis nga formula. So here we have a triangle daw. So we're going to draw the triangle, no? Wala mo sad gi-state nga unsa na siya nga triangle. Isosceles bar scalene. So wala lang, nalang siya base nga equal to 4 inches. And then napod siya height nga 6 inches. So height equal to 6 inches. Ma siya. So of course, we already know that the centroid of triangle is 2/3 away from the vertex and 1/3 away from the base. So somewhere right here. So imo din na siya kuan ayang centroidal axis. So mao ni siya iyahang centroidal axis. So centroidal axis O. Ato lang siya ikuan na denote as letter O. Now next is ingon mo siya diri no? Ang axis nga gipangita is with respect to an axis that passes through the centroid, no? And parallel to the base. And parallel to the base. So kaning centroid nga O, no? And this O daw is parallel to the base. Let's say ato na siya equal nga axis B. Okay. So makaingon mo, oh sir, ang axis din nga gipangita is the centroidal axis, then kay bao na ta. So mo ni akong gingon nga kung nagsunod mo, kung nagtanaw mo sa previous video, nag-touch dito no, gi-include dito ang derivation sa pagpangita sa polar moment of inertia, the moment of inertia of a triangle. However, the reference axis there is only at the base, not the centroidal moment, no? So if at the base gali for a triangle, so ato like ano from previous nga discussion, kailangan ito tan-awon para makasunod mo the moment of inertia of a triangle along the base or with respect to the base, that is equal to bh cubed all over 12, no? This is similar to a rectangle with respect to its centroid, no? Para na sila. sa triangle o sa rectangle, pero sa rectangle nga part with respect to the centroid. However, for the triangle, this one right here is with respect to the base. Mo rin nakuha, no? Wala nakuha dito ang moment of inertia of a triangle along its centroid. So, kani siya nga problem, we can still use the parallel axis theorem. Because again, sa ato ang parallel axis theorem, again, the moment of any axis other than the centroidal axis. So, unsa may naa diri, unsa may laing kanang kuan axis aside from the centroidal axis nga O. So, we have B. So, ato na ibutang IB is equal to, again, the moment of inertia along O plus the area of this triangle times the square of its distance. So, ang ipakitaan ni is DIO. Now, given man ta ni IB, mao ni siya. So, makakuha ta sa IO. So, therefore, IO is equal to IB minus the area of the triangle times the square of its distance. So, asa man di makitaan? So, kani siya, no? Kana siya nga distance. Now, makasolve ba ta for D? Class, makasolve ba ta for D? Unsa may value sa atong D diri sige daw. Uy, naka-follow pa? What is the value for our D here? Sa may formula. Remember that D is the distance between these two axes. So, unsa man? Any idea? Ha? Equal siya ni unsa man? Okay, distance of its centroid. Unsa man to distance sa centroid sa triangle with respect to the base? Kay numdum pa. Equal to pila man to siya? What fraction of the height of the triangle? Ay, to kalimti. We already derived that one. Ha? Okay, so that is 1/3. Ay, naging nakalimti. So, 1/3 times the height. So, that is the distance. Ato na siya apply. So, the moment of inertia of the triangle along the base, natay formula na. So, we have BH cubed all over 12 minus the area of the triangle. Again, di na gina makalimtan. 1/2 base times height, and then the distance is 1/3 of the height square. So, ato siya substitute. Base is 4 inches. So, 4 times the height of 6 inches cube divided by 12 minus 1/2. The base is 4. The height is 6 times 1/3. The base is 4 and then square. So, therefore, the moment of inertia of our triangle with respect to its centroid is we have 4 times 6 cube divided by 12 minus 1/2. We have 4 times 6, then we have 1/3 times the height, which is 6 square. So the answer is 24 inch to the fourth. So 24 inch to the fourth. So this is our final answer for the moment of inertia of a triangle with respect to an axis that passes through the centroid. Now, pwede po ninyo ma-derive ani ang iyahang generic na formula. So without without substituting the values of the variables here. So diri ata ato na siya i-simplify. Need to simplify this one further. So we have bh cubed over 12. Then can I siya minus 1/2 base times height. So we have 1/3 squared. So that is 9. Tapos h squared na siya. So simplifying further, bh cubed all over 12 minus 9 times 2 is 18. So bh cubed na po na kay square times h square times h cubed tapos 18. If we're going to add this one, so bh cubed 1 over 12 minus 1 over 18. If you're going to subtract this one, the answer is bh cubed all over 36. So naana kay formula for the moment of inertia of a triangle along its centroid. So again, nanakay moment of inertia of a triangle along its centroid, and you also have now the formula for the moment of inertia of the triangle along its base, which is equal to bh cubed all over 12. Okay, naipangutana ni? Wala na? So, let's continue our discussion for tomorrow. So, diri ang sa takutob for part 2 of moment of inertia for to the figures.